The following presentation was recorded at the NDS Public Conference in May 2022.
With the programs, I'm pleased also to show or announce the next demo from Sippel at BMW and Michael Kluge from dSpace, showing closed-loop testing of automated driving functions on NDS maps using OpenDrive. And yeah, it is interesting first because it is an automated driving, not navigation-related demo, and the combination of NDS maps and OpenDrive, reiterating the fact that in NDS we are supporting the development of an OpenDrive converters both ways, NDS to OpenDrive and the other way around. So the stage is yours, and please show us what you have implemented here. Thanks.
Yeah, thank you for the introduction and welcome. Yeah, as you already told, I want to talk today about NDS maps and how we use it in validation. Maybe I would start with some words about what I actually do at BMW. I'm working in the test infrastructure, so my work is to provide models for hill tests. And my particular responsibilities are with the environment simulation. So I handle all the requirements regarding the environment simulation, and that includes also sensor models, also maps, and everything related to that. Before I get into the content, I want to start with a short motivation. What's actually going on and how does our test setup look like? So in the center of our test setup, of course, we have the ECU under test. And for this ECU, we need to provide appropriate inputs. And of course, that includes an NDS map. At the moment, this is running on a head unit. So the NDS map is on a head unit. But of course, if your test setup could look different, that the NDS map is directly on your ECU under test. And of course, for the ECU under test, you need some kind of simulated world, simulated environment. And there you need to base it on something. So you also need a map. And of course, you need eager vehicle and traffic and everything that's moving around in this world, but you need a map. And as you can imagine, this map and the NDS map they need to fit, need to match, so that the ECU under test can do something useful with it. But what is the map actually for? And for that, I want to shortly talk about the SAE levels for automated driving functions. And if we talk about lower level driving functions, the driver is always responsibility. So the function is only supporting the driver, like with holding the speed that you can drive or holding the lane. Maybe you can do a lane change, but the driver always has to monitor what the vehicle is actually doing and has full responsibility. So in difficult situations, the function could just, it could shut off, and therefore it doesn't need to be that highly sophisticated as for higher levels. You only have, in most cases, only one-dimensional movement, so you only need limited information. So, for example, if you see no lane on the left, then you just won't activate the lane change. And the driving function is always able to switch off. But that changes when we talk about higher level functions. The driver, he needs to take over when he's asked, but in a limited time frame. So he has about maybe 10 seconds of time, and then he needs to take over. But if you can imagine, if you are driving at 100 kilometers an hour, 10 seconds, you drive quite a long way. And also a difference, the function drives autonomously and you have localization issues. For example, if you're driving in an urban area, then localization with GNSS could be difficult because you have high buildings and probably your GNSS connection could be blocked. And yeah, the function is also for higher levels, it can, or the vehicle can move independently. What does it mean, essentially? It means that we need a very sophisticated ground truth for our simulation. And how can we achieve that? We divided it here in two particular use cases. The first one is we said that this probably better suited for lower level functions that we convert an artificial world to our or use it in our simulation. And the second use case is that we actually use data of the real world, so the real map inside of our simulation. Next, I want to shortly talk about how our hill setup actually looks like. So we have some world representation on the top left, and that needs to be represented in our NDS map that's running in our head unit. And then we need an OpenDrive map for our simulation. And between that, we have the NDS converter. As I said, we do it both ways. So I, on purpose, printed the arrows in both directions because we can either start with the OpenDrive map or with the NDS map. Then we have to import it somehow in our dSpace simulation environment. Therefore, we need a dSpace importer, at least at the moment. And then we download the map into our hill in the internal map representation into the simulation, which also includes the EU vehicle and other moving objects that are necessary for our test. With the content of the environment simulation, we create ourselves an OSI ground truth, which also includes, or which is kind of abstracted that information, where are all the objects and how does the map look like. And that is used to feed our sensor models like radar sensor, LiDAR sensor, GNSS, and also parts of ECU functionality. What we can add to this is a 3D visualization, which is normally, or at the moment, mostly used to see what actually is happening inside of the simulation. But it could be used as well to feed sensor models. The output of the sensor models then goes to ECU under test, and then the ECU under test controls our ego vehicle to make it a closed loop simulation. Now we know how the test setup looks like, and now I want to talk about our first use case. And this is, we want to convert or use a synthetic world inside of our hill tests. So we start with an artificial world representation. Why do we use this approach? For lower level functionalities, because we don't need so much information. So we need, for example, to know about speed limits, maybe upcoming speed limits, and we have limited lateral movement. So the driver always decides when to change lane. We need to see lane markings, so all the basics. So your map you're starting with will probably look like the picture on the left. But we need to convert it into our simulated world, and this is our base. So the artifact we are generating is an OpenDrive map. What can we do with this? We limit the number of influential factors. So it's good because everything you put in the simulation, you have under control. You have the full control over the map. And when you want to change a single aspect, you change only this single aspect and nothing else. So you can easily cover a lot of variations or corner cases, and probably can even automate it and create the variations. But on the other hand, you need to build up everything by hand. So you can see it looks very basic, and you can, of course, make it look a little more realistic. like on the right side, but of course, this takes even more effort. And after you build your whole environment, you need to convert it into NDS. So yeah, I put in also a picture how this would look like in the NDS map. And of course, for that, you need an NDS converter to that the ECU actually sees the OpenDrive map exactly as we have it in our 3D simulation. That's it from my side. Michael will now continue with some details and challenges for this approach, and also with our second approach.
Thank you, Marco. I will share my screen and take over. So I hope you can hear me well and see my screen already.
We can hear you. We can hear you well. The screen we don't see in Frankfurt, at least.
You don't see the screen. Okay, then let me go back and start the screen sharing again. I have to click there. Okay, that was my problem. Yeah. So there we are again. Okay, so that's basically starting from the use case Marco just left off. Let me start with a small introduction. Also, welcome from my side to the NDS conference. I'm Michael Kluge. I'm from dSpace. I'm group leader and product manager in the field of roads and scenarios. I have been working on this topic for many years, especially or most interesting today in the context of road format conversion. I'm also as a representative of dSpace in the ASAM, where I focus on defining and creating new versions of OpenDrive and OpenScenario, but also OSI we have heard before already. dSpace and BMW have been working together on this hill simulation context for quite some time, so that's why we do this presentation here today together. So let me start with some background information on OpenDrive. OpenDrive, that's a quote from the official documentation from the ASAM page. It's an exchange format specification to describe static road networks for driving simulation applications. So a lot of interesting information in this small snippet. So OpenDrive was designed to work for simulations, not really with a focus to create visual representations of a road network out of OpenDrive, which is obviously possible. We have seen many examples, and we will see one later on. But the focus is really the simulation, also in real time, and also the exchangeability, so an exchange format between different parties. And one good example is for the ones of you who know OpenDrive is the way that junctions are modeled in OpenDrive. It's great for driving over them, but it's not so great for doing an actual visual representation of the junction. Nevertheless, it's successfully used also for this purpose. But there are some things you have to consider if you want to use OpenDrive for this use case. So let me continue. What I want to say, in OpenDrive we have this. We have the definition of the course of the road, and we have some additional information like those objects and their meaning, but they lack information about how they should be visualized. It's quite simple for a traffic sign, like in this example here, but it's really more complicated if you talk about like buildings and so on. So this is a really challenge if you want to do a visualization of this map, which maybe later can be used for sensor simulation or perception use cases. So this is quite important to select the right 3D assets for later visualization when handling OpenDrive files. But additionally, as Marco already mentioned before, it might not always be sufficient to take the information from the OpenDrive file and create a really realistic environment of a scene, because this would mean that you would have to put a lot of effort into this OpenDrive definition, and it might not always be possible. So this option to manually extend the surroundings of the road itself might also be still, if you use OpenDrive, still be necessary in addition to this. Yeah, so basically an automatic scene generation is possible in starting from OpenDrive, but it might lack some detail in the surroundings. So that's why we need both directions. We have to take the OpenDrive file and create the basis with maybe some additional objects. You need to have some information on how they should look like in the 3D world, but you also have to provide the option to make some additional modification to this. So that's a starting point for this use case one, the synthetic world. You can create simple scenarios with really focused use cases you want to show, but basically you are limited in the complexity you can achieve. Like within this use case, that's what leads us to the second use case when we talk about maps as a source for OpenDrive files. And going to the second use case, the real world use case. The real world itself is like it's a map you can have from your map provider. This is then provided to the head unit as an NDS map. And if we want to bring this into the simulation, we also again need the NDS converter, which creates an OpenDrive representation of the NDS map, which then can be moved to the 3D world representation for sensor simulation and so on. Okay, so then let's continue. It's as we can see on the right side in this example, it will be quite hard to create those complex scenarios, as we can see here, manually by creating an artificial map. So that's why we want to have this use case. We need this use case to reflect the complexity of the real world in the simulation. And the HD map data is actually the key to get there. So and that's why we need also this use case, this workflow we see on the top. But what is also really important here is that let me shift my windows here a little bit. That as Marco has said before, especially for higher levels of automated driving functions, level 3 and up, we need a lot of detail in this map. We have this detail here in the NDS map in the head unit, but we also need this detail in the OpenDrive map for the simulation, because as Marco said before, localization via GNSS might not always be possible. So we need to do localization based on additional content in the scene, like traffic signs, some unique buildings, maybe some road furniture like guardrails or buildings or vegetation, whatever. Those information also has to be present or has to be known also in the simulation. So that's why it has to be up here in the OpenDrive representation of the map. So that's one major benefit that we would have with this use case, but we need also this level of detail in the OpenDrive map. Which is the next point when talking about this use case is that map data is really or can be quite huge amounts of data, and that's why it's really important to identify or to find the relevant situations in this complex environment. So you have to have an option or a way to identify certain situations or combinations of roads or whatever you need in this complex map in order to work properly in this approach. So for example, if you need a two-way highway exit, but you have a map of the whole of Germany, then it would be quite cumbersome to look for those situations. So it would be really great to have ways to find those situations somehow in the map data in order to make this workflow work efficiently. So as we have seen, real map data is the key for simulating more complex environments. So then let's take a look at one example on the next slide. I have created, with the help of Marco, we have selected one small, simple example from an NDS map. On the left side, you can see the visualization, which you can also use. You can see, you will see later in the video. You can also use for sensor simulation. On the right side, you see the output of the OSI, open simulation interface, which is also used, which is also produced by the simulation actually. I will go into this when the videos are running. So they are running like synchronized. As you can see, it's in quite empty surrounding here, but that's the result of a completely automated conversion process. We are located in Munich, so especially in the surroundings, there would normally, in reality, there would be a lot of buildings, but okay. On the left side, we now see that that we have in this simulation, we can also do like things like radar simulation. All the things that you can see here, that those traffic lights and traffic signs have been placed automatically. The vehicles that drive around are obviously not part of the map, and that's things that I have created afterwards. And on the right side, in the OSI view, you can see, okay, we have in the surrounding of the vehicle, all the lane markings are identified or known by visualized by those red points. All the vehicles that move around are visualized by those blue boxes because the vehicles have bounding box information. And as you can see, okay, we have a great representation of this map in the for OSI and for visualization and for sensor simulation. Okay, let me jump to one specific point here in this map. So the junction we have seen before, as we can see here, a lot of those traffic signs are automatically converted, which are coming from the map, or automatically converted to this representation for the simulation. Marco and I are investigating. We expected a little bit more, some more of those traffic signs, for example, in the map, and there could also be some additional things like guardrails and so on. But the basis is really there, and you can do a simulation at this with this level of detail. You should focus on the lower levels of the SAE scope. On the right side, I think you can. I will jump to the same position. You will see all those elements like the traffic lights and the traffic signs and all the other vehicles also here in this OSI representation from the simulation. And jumping to the last point, which is also very important, that the simulation also simulates the GPS positioning of the vehicle, which contains the system under test. So this is also done based on the information given in the OpenDrive file. There is the local, the position of the map is defined in there, and if you drive over the roads and so on, your actual current position is also simulated. So we need additional information, but we also still need in the simulation the GPS position of the vehicle. So okay, and again, as we can see by this quite empty surrounding of the road, also in this use case, you would need the option to manually extend the contents of the 3D world if it's necessary for your use case. This option should still be should still be provided. So let me summarize what we have seen now. The first use case is starting with in an artificial world. You can really focus on the specific test case and situation you want to test, but you can still create situations that might not exist in the real world. So you can cover all kinds of corner cases you can think of, and you can really do a requirements-based test of your driving function. You should for sure have the manual effort for creating those artificial maps in the first place, but that's obvious. Going to the second use case, to real world use case, we can get more really complex and close to reality scenarios and environments to the simulation based on the information from the map. What you do in the simulation can later be compared to what you can do in the real world testing with your vehicles. You can compare those things you have learned in the simulation and later on in the real world driving. What I said before, the identification of those relevant situations is a really crucial point for this topic. So how to find the correct situation or the correct part of the map you want to use for your simulation. And what is also very interesting to consider is that if the map changes regularly, if you have like a roadwork situation on the highway, which is represented in the map, and this changes hopefully quite soon. So it's kind of hard to compare those results of the real-world based simulations if the map changes and therefore also the OpenDrive changes regularly. That's something you have to consider. So in general, as a summary, the converters are already successfully used. So the OpenDrive to NDS and vice versa, converters are already successfully used in driving function development in both directions, and both directions are necessary for the use cases we have seen. And the higher levels of automated driving autonomous driving functions require more details in the OpenDrive map to allow this localization, not only based on GPS positions, but also based on things around the world like traffic signs and buildings and so on. So that would be my summary for the slides, and now we only have this questions and answers slide at the end. Thank you very much.
Thank you very much for this great insight into using maps for testing and simulation of ADAS and AD related systems. So I liked it that we are not just talking about features and functions, but also how to validate the systems. And it was important to see that maps are an important element of this testing and validation chain. So thanks for that. Do we have any questions in the Q&A? Okay.
Questions in the room.
Question in the room. Hold on. So that with the micro, everybody can.
Thank you.
Yeah.
Andrei Sharadi from Comsignia. So the question from my side is, does this testing ecosystem support e-bikes or bikes in general? So both from a map point of view and also from a representing bike as an entity in addition to a car entity point of view. Thank you.
Did you, Marco, did you get the question?
Yeah, I got the question. So I will answer from the OpenDrive point of view, or maybe also open scenario point of view. So maybe Marco can go into detail about the map topic, but I think OpenDrive generally allows the definition of bike lanes. So this is possible in OpenDrive, and therefore it is also possible to visualize those bike lanes in those OpenDrive maps. And also open scenario, if you think about like definition of the behavior of the participants of the scenario, also allows the definition of the behavior of bikes, e-bikes, whatever. So from the standards point of view, this should be possible. I don't actually know how maps support those kind of non-vehicle or non-car domain lanes in their data.
Yeah, those lines are supported, but of course you can't define a bicycle inside of OpenDrive, only the lane. But in the ASM simulation from dSpace, of course, you have other objects than cars. Of course, you have normal traffic participants like bikes and people that are walking, maybe people in a wheelchair, stuff like that.
Yeah.
I think also from NDS point of view, we don't make any assumptions about traffic participants in general. So it's about the maps. If there are bike lanes, then we'll be able to include it.
Thank you for watching. Visit our website for news on NDS at nds-association.org.